So I want to say welcome everyone to experiences using Grails and a microservice architecture. I want to just start by saying please ask questions, interrupt during it. We have plenty of time. That's the beauty of Spring 1, so we can interact and dig in and hopefully get everyone's questions answered. And if I can't answer during the talk, I'll be happy to connect with you afterwards. I'll give you my Twitter handle or email or something, and we'll talk offline and get all the details sorted out as much as possible. So, and if I actually just don't know the answer, I will try to find someone that does, because I feel like I should do that. So I think I'm going to go ahead and start. We're at 10:30. Oh. Okay, so don't scoot the laptop to the left. So who am I? My name is Jeff Beck. I'm a tech lead at Reach Local, and I'm Beck J01 everywhere. GitHub, Twitter, anywhere you want to get a hold of me, but the best place is actually Twitter. And like I said, I try to respond to any questions people have, especially about talks, or refer you on Twitter to someone that does know it. So to start things off, of course, what I mean by microservice, because we've heard about them probably the entire conference, and I just want to make sure, once again, that I'm talking about a single concern and deployable in isolation. And what I really won't be talking about during this talk is how big a microservice. Like, I've already been asked that question. I won't talk about that during the talk, but if you want to talk offline, I'm happy to do that, because that just becomes a nice argument of the perfect size of a microservice. Deployable in isolation, of course, and to really dig into what we have, I wanted to talk about what our architecture is at Reach Local. Over the course of a number of acquisitions, expanding products and everything, we have a very large polyglot architecture. We have a little bit of everything, and if you can name a language other than .NET, I guess. Oh no, there's .NET. Sorry, there's a product with .NET. So pretty much every language you can imagine, except for maybe F#, because I've never seen that in production. But I would love to, but no. We have everything. So in order to take advantage of teams that are very good at their respective technology, and we have microservice path. Also, besides that, better speed and a lot of other things that go along with microservices, which you've heard about the whole conference, I'm sure, about portability and isolation and things like that. Our architecture, which is blurry, sorry, I can't really zoom in on that. So just to kind of describe, I'll just give it, to describe our architecture, we have layered microservices. The idea is at the base layer, we have pure REST resources that just act as the responsible entity for knowing the state of some resource. Above that, back at this outer second layer, we have business logic resources that these business logic services will interact down into many resources, but they don't interact across that layer. And then stepping up another layer, we have our gateways, which kind of act as the bridge out to clients. And at that bridge, and then they work down to business logic layers and sometimes down to resources, but most of the time go through business logic. And once again, don't go horizontal. So we don't have the horizontal talk. We also have an asynchronous broadcast event system. And by broadcast, it's basically people fire events off, people listen if they want to, but there's no explicit pointing a message to someone. And we have REST calls throughout the system that can be either synchronous or asynchronous, depending on the REST call itself. So we'll get 201 createds back at certain times, and other times we just get we'll get the accepted for processing and move on from there. So where does Grails fit into all this? Especially for my team and for us, anytime we're doing a REST resource at that lowest layer, that fits really well for us, as well as Gorham. Anytime you can leverage it, I'm a huge fan of it, So I think anytime you get to leverage that as part of your microservice, that's a really good candidate to use Gorm and use Grails in general. But where does Grails not fit? Batch jobs. And if you lack any web endpoint, we're not really using Grails for that right now. One example of that would be we have a service that basically consumes these asynchronous events and then talks out to a REST endpoint. And that right now is in Spring Boot because it doesn't have any REST endpoints to talk to, and it doesn't need a lot of the data marshaling or everything because everything's stateless in that case. So it doesn't use Gorm, doesn't have web endpoint. We kind of skipped Grails on that one. Any questions about our architecture or in general? Yeah.
Obviously, Grails is running the container. The batch stuff is not.
The batch stuff would run in, it's not the same container. It doesn't run in the servlet container. We have Spring Batch admin, though, running in the servlet container to actually give us the UI. But the batch jobs run kicked off by cron. Yes?
So now that Gorm can be run in the boot app, are you considering moving the architecture from Grails to a boot?
Right now, no. Because we have a lot of plugins and we do a lot of marshaling for the REST applications that we're doing a lot of marshaling anyway. Grails does that really seamlessly, so we keep using it for that. Yeah, I really like that you can use Gorm in boot now, and as we all know, that's kind of the steps to Grails 3 though. So, yeah. Yes, a little bit of everything. It's the best way to say it. The goal is to consolidate on a smaller tech stack, but not necessarily deprecate everything. Like Perl's going away, but Rails and Ruby isn't. So I think I'll move on to the example service. So this is kind of a case study of one of these REST services that I've been talking about. It's a subscription service. And it's the one source of truth about subscriptions for this. And this is a subscription to a particular product. It's a pretty narrow domain, but it exposes just a pure REST interface, and then it emanates events through that asynchronous channel. So a requirement for our apps, of course, is application monitoring, security, server setup, builds, and deployments. This is kind of what any app that wants to live needs. So, building our Grails service. So all of what we do in Grails microservices start out the same way. And one of the things I've seen in Grails 3 that I find very exciting and I'm looking forward to is the idea of profiles and being able to have custom profiles to set up a lot of this kind of quick setup of an app. And I think that'll be really exciting. So we do Grails create app. Right now we move to Java 1.7 and we add our internal Nexus as one of the Maven repos because we're going to use a lot of internal plugins and things like that. And the first thing we want to do is make sure that's in there. Now we want to set up our plugins the standard way. We're going to add Cucumber, code coverage, the Grails console plugin just out of the box because that just makes everyone's life easier. And we remove scaffolding, asset pipeline, jQuery. Because we're doing all REST, we don't need any of those things. And we get to trim down our war size a little bit because of that. Is there, okay. So now we go in and set up our Cucumber plugin. So just installing it in the build config is one thing. We set up the glue and everything, and then we set up and configure Gorm. The reason I call this out is we don't only use Hibernate. We actually use Cassandra through Gorm a lot. So there's not an in-memory version of that, so we have to set it up to point to a dev box and things like that. So there's a little more setup in the base case in our world. At that point, we commit everything. That's our starting point. And we then create a continuous integration job and bring up a dev server. So that's kind of the line in the sand. Everything is now customizing. So we're actually following, in these cases, a little bit of BDD, especially around our REST services, because it works really well for us. And so we'll add our scenarios right away, and we'll get a failure, because never trust a test that doesn't fail. You always want to have a test that has failed so you know that you're actually testing the right thing. So we start with this. And one of the things that works really well with Cucumber is between these two somewhat different, we're testing a 404 and testing the 200, so we're testing the negative case and the positive case. Those two scenarios end up only generating two different givens. And then the same wins and thens are able to basically reuse our code. And that works really well because I get a response ends up being reused very, very frequently across all of our REST endpoints, because it's very simple for us to say, in the Cucumber, I get this response, and it's just that rule's already built out in our step definitions. So we have lots of these Grails applications. We've spun up, I think we're up to 8 to 9 on my team of 3 people alone, running in production. So we have a lot of reuse, though, that enables us to do this. So we reuse health checks, security, the server setups, the deployments, and the Spring integration components. I'm kind of going to go through how we reuse each of these things and talk about how that works. And if there's any questions about why we didn't reuse other items, things like that, feel free to jump in. So, in general, with our health checks, we have a health check standard in the company that allows operations and everyone to have a really known way to check whether or not a server's up. And that becomes very important, and you get that for free with Spring Boot. Grails, you have to add it in, but we want to have a standard that works for us. So an example of our earliest health check standard is here. And so we just want a plugin that can help make that easy for us. So what we did is via a Grails plugin, we share any Grails-focused health check implementations and a controller that actually generates the expected output and has the URL mapping set up for us. So as soon as you put this plugin in, a health check's going to return. So it basically validates that your Grails app is up and running out of the box. So given this and the kind of skeleton work we've done before, we should now have a deployable app that at least spins up, validates that the boxes are running, and everything's working. But we actually went one step further, and we're sharing outside of Grails as well in this case. Because like I said, we have a big polyglot architecture, and we have Spring MVC apps as well that are out there. And we actually have a common jar now that does the health check implementations that are generic, like check if a file system's there, make sure you have right access to log directories, and whatever important health checks can be shared across every JVM application that kind of works in this stack. And also the actual registry of health checks and how we maintain them is all shared now in this jar. That jar is then consumed, of course, in the Grails plugin, and then we enhance it with the Grails-specific things. But this allows us to reuse not only within Grails, but across other JVM applications. So it works really well for us. So security, another concern that needs to be shared across basically all your microservices. We do server-to-server auth with a token right now. And we built a simple plugin to support that. We expect Gorm object that has, it's basically called auth token. We expect that to exist in the database. It does work through Gorm. It makes sure whether or not the ID exists in the database, and that will do it. We have a static list of what resources to lock down, and then we intended this to be as lightweight as possible. So actually using it was a bad idea. Don't re-implement Spring Security. It just go use Spring Security. What ended up happening is we were doing opt-in security, which made it very easy to miss a controller, because you don't want to do blacklisting, you want to do whitelisting out to whitelist out of security and things like that. We intentionally lacked roles because we didn't have a use case at the time. And we now have found a use case where we want certain tokens to give people read access and certain to give read-write access, read-write update. We don't support delete anywhere, so yet. So what we're moving towards is this Spring Security-based plugin, but it still uses an auth token. It's just built into that framework and is much more in line with the rest of the way Grails works. Any questions about our auth? All right. So how do we actually share these plugins? We use an internal Nexus repo, and we release the plugins right to that. The good about that is it supports versioning. The dependency resolution works just like the rest of the way Grails does. Now, I say that because if you're using older versions of Grails, not the 2.3, 2.4 series, but if you're in the 2.1, 2.2, and you use internal plugins or inline plugins or just them on the file system, dependency resolution works very differently for those compared to the ones pulled in from Grails Central. And in general, it works a lot better if you just have them in a Nexus repo. One of the problems, of course, now is changes don't reload. So if you're used to being able to just quickly edit, it's not going to work. You're going to have to release a new iteration of that plugin. So in general, the guide is, for all internal plugins, you need to tend to add features allowing customization. So one of the key rules is don't use private variables and things like that. Allow users to overwrite them. A really great example of this is actually Beck with Spring Security plugin, and he's done a few talks about how to make extensible plugins, and following that's really great. Every project, though, every one of these plugins is a project in itself. It needs CI, it needs code narc, code coverage, tests. You have to treat it like a first-class citizen. And what I've seen happen a lot is in less mature organizations, you'll see someone making some plugins. They just kind of get slipped out there because I can post, like, you're going to do Grails publish plugin. It's not part of the CI. It's fine. We're testing all the apps that use it, so it's OK. And you end up with kind of buggy, ill-maintained plugins. And what you want to do is really treat these plugins as a first-class citizen in your architecture. Use versioning. Don't release everything as 0.1-snapshot. I've totally done that, and it's bitten me. I mean, I will admit that I have things that have stayed on snapshot for too long and not done releases. And in general, having the CI pushing out snapshot versions is very helpful, these plugins, because you're really realistically only waiting for that build to run. And you can even defer it so that it kicks off anyone depending on that snapshot. You can make your build system do that. But it's also very easy to not then release plugins. So if you can, I would suggest making a part of the gate to saying something's good enough to go to production is removing snapshot versions. Now, every once in a while, that becomes very hard with plugins that are external to you, that you're using. If you're saying the newest version of Grails and they have a bug fix and it's only in a snapshot release and it hasn't been merged into mainline yet, that becomes very hard. So it's a lot of give and take, and just kind of use your best judgment. But it's a first-class citizen, and try to not use snapshots as much as possible. Yes?
Do you let the CI create the version numbers for you, or you put it in your plugin?
So for the plugin, I let the plugin define the actual version number because the entire thing is semantically versioned then. on our artifacts that go out to the deployments, that is actually controlled by the CI server. Part of the artifact numbering is controlled by them, and that's something currently in flight in our company. And RelEng really wants, our release engineering team really wants to control part of it. The developers, of course, want to develop part of it, and there's been a very good proposed solution by Joshua right in the front row, where dev would own the first two numbers, and the patch and build numbers would be owned by RelEng. So the shared responsibility, and I think that's a really good move. And for plugins, though, in Grails, most of the time, if you want to get your CI server to run it, it's going to take you a little more work because the plugin where the plugin numbering is inside of a Groovy file, and you kind of have to depend on Grails to build and release the plugin. All of that, of course, will go away with Grails 3, and we'll be able to just use Gradle, and it will integrate a lot more smoothly, especially like building plugins. So, all right. So the server setup. We currently use Puppet, and just using a configuration tool isn't enough for microservices. You really need to have a strategy for reusability in your configuration management. So what we have is a single, we call them skeletons, and they're classes that you implement and can inherit from that will deal with setting up Tomcat, for example. So just to show you what our standard, so this will set up pretty much everything we have to configure for a Grails app to run on a standard Tomcat. And it also includes monitoring. So we also have monitoring brought in as well. So the nice thing is you'll notice we have like 3 settings. And there's not a lot for us that we have to mess with to get this to work. It just, we have teams that maintain the standard, that standard Tomcat 7 web server right there. That's what we call a skeleton. It's just a Puppet class. But by doing that, it really pulls in everything we need. You'll also notice that we include this subscription APIs config line. And what that does is pulls in this file, which will generate our external config, which is a Groovy file. But we have a really fun time where it's a Groovy ERB file, because what we do is we use ERB, and a Ruby templating language, to generate a Groovy config that we then pull into Groovy. So what I can tell you is I have more than once written a comment in the wrong language and had that bleed into a configuration and then crash something. But you test everything, and it's in dev, so it's fine. No one cares, because it doesn't get into something anyone besides you sees. But that's one of the biggest areas that I've actually had issues with is we use Jira, which is part of Puppet, that it kind of stores all the values that we replace. Making maps in that system and then trying to get those as maps in Groovy, you're going to have some trouble. It's going to be a little hard for you. That's something it'd be good to work out. And if anyone comes up with a really slick Ruby solution, let me know, because I would like it. Is there anything? All right. I should stop asking. So deployments. Right now, all of our deployments are custom bash scripts for the Grails wars. We have other deployment methodologies for other technologies. We use Capistrano in some places and things like that. Right now, all of this is kicked off by Bamboo. And the really nice thing is our release engineering team has it down to, we have 3 things we have to change per deployment. The server list, aka which boxes does this war go to? What is the name of the war? And setting up deployment permissions to make sure I'm allowed to press the button to deploy to dev and QA, but not production. And that's all done in Bamboo. So it's really essential that you have this really quickly reusable deployment, because if you're talking about microservices, you're not spinning out 3. You're spinning out 10 or 20 or maybe more, depending on your design and your architecture. And 10 or 20 different significantly different ones that all need to be deployed, and the more you can streamline that process, the better. We also use Spring integration. And one of the items in Spring integration is all of the components that we wanted to reuse across not just our Grails app, but our Spring Boot app, like I talked about before. We want to reuse those components all across the JVM. So we just made a simple jar for that. Because really, we didn't need Grails to provide anything special in that case. And one of the beauties is we can just use a jar easily in Grails, and there's no problem with that. So we expose a POJO, not a POGO, unfortunately, but that represents what we think of as an event. We also have a deduplication filter because events can be, of course, received one or more times. And so a standard thing we want to do is deduplicate those events at quite a few, not all of our systems, but quite a few of our systems. So having this as a standard component that we just plug in is very easy. And then we also, we have a special event deserializer now because what we ended up doing was our event object has a builder to build out the event, and it's then ends up with an immutable map and things like that. So because of that, we couldn't use standard JSON to object deserializers in Spring integration. It's very easy to write your own, but that's something you definitely don't want to write in 4 places. You want to have that as something shared right away. And we also try to make this jar include the least dependencies possible. And the reason for that is in our microservices, we may have a Grails app at 2. We have Grails apps at 2.3 and 2.4. And we have a few, I think they've all been upgraded now, but for a while we had a few at 2.2 that were on their way to be upgraded. And because of that, you end up with a lot of different version numbers of dependencies. And so with a shared jar like this, what you want to do is keep the number of dependencies as low as possible. So if we can do something in just Java and it takes a few extra lines of code, it tends to be a little better than bringing in yet another library to fix everything, because that just bleeds out everywhere. So logging becomes a huge challenge in a microservice architecture because I make a request to this thing, and it will then span out across this graph of services. And what we use is a correlation ID right now. And the fun part is with a little bit of, since we're using Log4j, we depend on Log4j's MDC to actually put a correlation ID in. And when we do that, we're able to add a correlation ID if it doesn't exist, or if the one does exist through our standard correlation ID header, we'll just put it on the MDC. And then in the enhanced pattern layout down here in your Grails logging, you're able to do this %x and then just ask for anything out of MDC. So nothing in the app has to know about this correlation ID, and it just will be on all your log statements, which makes it a lot easier to then use a log aggregation tool, which I'll talk about. Oh, and if anyone's interested, there's a link right there to the actual Grails filter we use that will, check the header. If there isn't a correlation ID header, it will create a correlation ID and log a warning, and then move on. But here's some correlation ID pitfalls that we've hit. So like I said, the filter always throws a warning whenever it gets a request without a correlation ID, which was a mistake because our load balancer makes calls that don't have correlation IDs because it's a very simple load balancer call. So because of that, we now have a very noisy log of health check requests with no correlation ID over and over and over again. So that's something we fixed, but in our naive implementation, we missed that. If you want to pass this correlation ID on to further systems, all we've taken care of right now is logging within our own system. What we've done, if we know about the HTTP client, it's very easy to interact at kind of a meta-programming layer with the HTTP client to make sure that header gets added to all outbound requests that are internal so that we know that the correlation ID flows through the system all the way. But if you need to somehow pass the correlation ID around explicitly, it becomes very messy in your code and it's very explicit. I personally don't mind it. I have other members of the team that do very much they don't want to see that correlation ID on a lot of methods. It's not something that really bothers me. We've actually gotten around it and been able to do everything transparently so far. But if you run into a situation where it's not feasible to do it transparently, you're going to have to explicitly pass a correlation ID around. It becomes a little more burdensome, but still worth the effort, in my opinion. So we use Splunk right now for all our log aggregation. And this is really important because we can do really fun things with our correlation ID now. So if you look at this, that's a Splunk query down there. And what's happening is we're telling it that one transaction is withheld in this field called correlation ID. And since we were outputting that on the log statement, it's able to, with a correlation ID equals and then the ID, we're able to then have Splunk wrap this all into a transaction. So when you look in Splunk, you see a grouping of all of the requests that happen. This is a really naive query though, because you notice I put keep evicted true. That's because I didn't actually search for anything. I just told it to show me everything and group it together. And it doesn't really like doing that because it's not really useful. But if you do keep evicted, you can see it. It's a good way to play with it to get started. One drawback about using Splunk right now for us is we aren't using it in our QA environment yet. But because of that, you still have to go back to potentially grepping through 5 or 6 different servers' logs because you don't have it. So I would highly recommend using logging in every layer if you can. Maybe not dev because dev's expensive and throwaway, but QA and up, it's very important to be able to quickly grep through your logs, get through it. It may not be, maybe you don't use Splunk, maybe you use a cheaper system for QA or something that maybe you use Splunk but only lasts a day or 2 days or a very short period of time opposed to production logs, which you want for much longer. Yeah.
Explicitly write log out all messages, or you use like Apache in front of tomcat to logging like the request key and header ID?
So
Implicitly write in each like request like logging out.
yeah, I'm just talking about the logging within the Grails application. We don't have something that's explicitly being like an access log right now, like Apache or something. And most of these all these tomcats don't have an Apache fronting them. So they're just exposed as just the tomcat and just the servlet container. So right, if we wanted to do that, right now, just logging at the issue, like logging at the layer of what's happening seems to work well enough for us. If you have a need though to log every request that comes through, then you'd have to do something like that. We also have centralized monitoring, and that's a must because not only are we talking about a lot of logs to grep through, but if you have this many servers, you still have to get through them all. So our centralized monitoring is Nagios, New Relic, and we're starting to use a set of dashboards that hit those internal health checks that we've talked about. Yes?
I just wanted to point out that we don't use it, but Tomcat can actually do access logs. You just have to configure it as a separate valve.
Yeah.
I mean, but it takes the standard. It takes the standard Apache log format string, but then you don't have to have Apache for that reason. You can enable it, but we don't at
Yeah.
at the service layer.
Thanks. So, sorry. What was said was, for the camera, that it's something you can set up at the Tomcat layer, but it's not something that we have set up. So you can set up a valve that will do access logging for you. So this is what New Relic, I've blurred out the names of everything so you can't really see, but this is an example of the New Relic map feature. And so with Grails by default, you get pretty in-depth cross-application logging. And what's happening here is you'll see 3 separate applications. The one in the middle is the subscription API. And what's happening is we have 3 different things calling, and those are all monitored by New Relic as well. And then you'll see it also goes out and hits the database. So you have this end-to-end transaction monitoring, which makes it very easy to look across and visualize everything that's going on. And I think you have to do something to do that, and it's a very important thing. We also use, I don't have the screenshots of the view, but you're able to drill into many transactions in a tabular way as well if you don't like the map, and see exactly what's happened. All of this is provided by just the standard New Relic plugin and jar. But if you want to use Grails and New Relic in a much more in-depth way and want to be able to look at requests coming in from the controller to the service to any other libraries and then response, you have to use some custom tracing. So in particular, we use a lot of services in our design. We do very thin controllers, and almost everything is shoved into the service layer. And what we have here is we have to add the trace, and that just comes in from the New Relic API jar. And we have to, in our New Relic YAML, enable custom tracing at that point. There's a little blog post there that will walk you through getting it set up. It works very well, and once you've done that, you'll get a very detailed log. And what we've actually done is some of these shared jars that are shared across Java and Grails, we've put the custom trace annotations in as well. So we can see, for example, a call comes into the subscription service controller to create a subscription. It will then make a call to the subscription service. The subscription service does some logic to do our indexing because we're doing Cassandra, so we're manually updating the index. And all of that's traced separately, so we know how long that took. And then we actually make a call out to our event system. And that's a jar that provides us an event client. And all of that's traced as well, so we can actually see how long the round trip takes to generate the event. Once the event's generated, we then end up returning back that everything was successful with our subscription. And that all works very well. And then in New Relic, you can see very detailed where everything's happening in your bottlenecks. And particularly if you have the trace at that fine-grained layer, you're able to then also see, oh, it's a call in the event service, and you can go look on their side and see it's not a problem. Like everything was quick on their side, and you know, oh, it's the network, it's the pipe. Like I know it was fast here, I know it was fast here, so it had to be the pipe, and you can go diagnose that, because you're going to have lots of subsequent calls, and there's potential for network latency that will drastically reduce performance. Hopefully not, but it happens. So another concept that we're using is compensation. We want to count for failures across the system by building a convergent system. So instead of the system having a failure and having someone have to deal with the fix of it, we want it to eventually converge on the right state. So right now, we're using, we're starting to use, I should say, this is a relatively new effort. We're using Spring Batch for the jobs, batching up the work. That then takes care of posting to a RESTful endpoint that will actually do the logic of, for example, with subscription. If we have a record that says, oh, it looks like someone paid, but we don't see their subscription, our compensation job says, oh, make sure this one worked. It posts to this business layer logic that should have created a subscription the first time, but it didn't for whatever reason. The same logic then can get the data again and go through, and it allows us to reuse the libraries very well. We make sure it happens, and the work that would have happened in real time just happens, and we converge on the same state. And this compensation is a very important part of this distributed asynchronous architecture. So I want to go through a lot of the pitfalls that can happen in a microservice architecture. We have poor communication between teams can get much worse. Because you're not required to collaborate on the same code base, if you're not good at talking to your other team, you just simply don't have to anymore. And then you end up in two separate places and you don't share code, and a whole lots of bad things happen. So coordinating releases. This becomes problematic because you have so many moving parts. And in my opinion, what you want to do is just not coordinate releases. You want to build things in such a way that they have backward compatibility. And it's a hard thing to do, and it sometimes requires you to, a simple change, for example, of changing a field name may now take 3 months because you have to support the old version of the field name and the new version of the field name and move slowly through that process. But in general, you no longer have to do these big bang releases and kind of release everything all at once. Another pitfall is development to spec versus finished service. So as part of these microservices, they're all REST and at the layer we're talking about, and it feels like, oh, it's very easy. I'm going to implement to their spec, and everything will work when we go together. And then, of course, sometimes it does, and sometimes what happens is during the process of them implementing to the spec, they find either the spec isn't good enough or there's a hole in capabilities that you say, oh, I can't do this anymore. And so it's always better to develop against the finished service, but that's just simply not always feasible. And it just becomes hard and a lot more frequent in a microservice architecture that teams are in very, very different spots of the life cycle of it. Another pitfall, of course, is leaving in snapshots. I've done that. I've messed things up. Not so much recently, thankfully, but it's happened. I assume it's happened to everyone here. And if not, good job. Poor monitoring in lower production environments. So what ends up happening is it's a lot of work to monitor this huge system and to make sure it's all running smoothly. And that happens in production. And then as you go down the stack from pre-prod to QA, it becomes less important to monitor it to certain people. And that's really bad because what ends up happening is it's very hard for you to test your app that may interact with 3 or 4 other microservices because those microservices are in a bad state. And so what some people will do is then they say, well, my dev boxes, I know those don't work, but my dev box can just point to everyone else's QA. And you get this interesting situation where you'll sometimes test up a layer and it works at dev to QA. It really falls apart because you can't do that QA to production. So you really want to treat your QA environment as a much more stable. It needs to be a much more stable environment because it's not just you depending on that box anymore. It's everyone else that consumes your microservice is interacting with it. Another one is I've touched on briefly is lacking log aggregation in lower environments. So if you don't have log aggregation in your lower environments, you're going to have a lot of time swunking through many logs. If you can do anything to get log aggregation, even if it's just getting them the raw logs on the same folder somewhere that you can at least grep across all the folders, that's really helpful. Yes?
I'm just curious about what the spec is
So there's a couple things we've done, and it's worked well in some teams and not others. And when I say this is a pitfall, I still feel a pain of that sometimes. It's not as bad as it used to be. What we've done is tech leads, the people running the kind of each group, try to talk quite a bit, and are highly encouraged to kind of share what's going on. There's nothing very formal about it yet, but in particular, there's a team that we've never been very good communicating with, and I have to be very conscious to just do a better job talking with them, because what happens, in my case, I have a trouble communicating with ops because I'm so focused on running in my direction, developing everything I need to develop. I don't do a great job. I didn't used to. I try to do a better job now. When I first started doing these microservices, I don't know if I did a great job saying, okay, well, we're going to need these 5 new servers, and by servers, I actually mean clustered servers, so you guys do whatever you need to do the 10 or whatever that balloons out into. And then what we weren't doing a good job of is kind of looping back. But server to server communication, that's one team that really gets worse with this. Is we were working with a team in the Orange County office, and we were working on implementing features they requested for updates to the REST API. And what ended up happening is we went through our process and didn't really say anything. And they had to then constantly raise up that we were blocking them. And like, well, we're done with the development, but we didn't do a good job communicating to our QAs that were on our team and their QAs, hey, we have to actually expedite this into the top of your QA stack so it gets up there and can be tested and move up, because we just didn't do a good job coordinating across that. Having a project manager that sits across the teams, especially when the teams are coordinating on a project, helps, because they can say, oh, you're dependent on this other service, let's see where it's at. I don't think there's a silver bullet.
Coordinating the releases, does the API version help in that?
Yes, if you leave all your old versions. But part of that is also you have to coordinating releases. I don't think has been a huge problem for us, because we've made sure that all our Puppet changes and things like that can roll out at any time. But coordinating releases also has to do with not just service to service and API versioning, but like you're updating from different patches of Java and things like that. Most of the time it's not going to break everything, but every once in a while you may have a breaking change or something you have to fix. So it's also internal to that. You have to coordinate. In particular, our Puppet changes usually take 3 releases to finish. So what we do is if we're changing a config value to a better name, usually is what's happening, is we realize we poorly named something and we want to make it cleaner, is we enter the new one, and then we change the app first to look for both and take precedent of the new one. And we've made Puppet use the same values from higher end everywhere else, just output them into the 2 different names. And then once the code and that is both in production, we take out Puppet, and then we can back out the Grails part that looks for both properties in Grails config and knows how to pick which one to use and things like that. But yeah, it takes a while to do it that way. And I think that's the right way to do it, but some people find it slow. So
You don't deprecate earlier versions?
in the APIs, eventually we will. We haven't run through a full deprecation of an API version yet, though. So that's most of our updates have been feature additions, not subtractions so far. So we haven't had to deprecate an API and say, okay, we have to stop supporting this. And deprecation of APIs becomes very interesting. If you're talking about a pure REST resource, you always want to support both versions if possible until you've decided to your deprecation strategy and then removal has to be coordinated enough to say, what lead time does everyone else need that's using this to remove it? But I've heard people say, well, I can't support both at the same time because the changes are too drastic. And my response to them is always, are you sure it's the same resource still? Or are you just naming 2 things the same name, 2 different things? And so I always try to see if there's a way to make a more pure REST resource that is something that doesn't need to be deprecated, and it's just the new thing that happens to, you slowly let that one wither and you move it away, but it's not this, I can't make these incompatible versions work. Yes?
Before question, but how are you handling latency as well as performance?
So latency and fault tolerance? Well, so fault tolerance, one of the major ways we deal with it is actually the compensation mechanism. So if the REST call fails or an event doesn't get processed properly, we know there'll be a compensation job that comes along and compensates for that. We also have retry mechanisms in some places, not nearly as many as we should yet, and that's something we're adding more of. In particular, even our app that talks to Cassandra, our REST apps, they all have many retries. So it'll try to write and it'll actually downgrade the consistency level that it's required, and will try, I think, up to 3 data centers even. So there's lots of retries and failover built in at that layer, but if that thing completely fails, we depend on a compensation job to come in and make sure that that actually gets processed. And yeah, there's a lot more we could do with retry queues. We've looked at Hystrix a little bit for circuit breaker pattern, and also there's a Spring circuit breaker as well, that they all look really good, and we would like to use that a lot more, and I think that's something that's important. If you're coming in fresh, I would add those as requirements right away. When we were coming in, we were still learning quite a bit. So yes, I would add those in, and I think they're a really great addition, especially circuit breakers. So, oh, sorry. Yes.
Compensation jobs, if it failed the first time and all that retry logic and all that, why would it work when the compensation job went through it? Could it have changed at that point? Or?
So the compensation job accounts for failures of the case of networks no longer was broken and is now fixed, or that whole service was down for some reason. But yes, if it's a code bug that it just can never process that record and it still throws the error, after the compensation job, I think the best practice is to then route that to a ticket or a manual queue to then pick it up. But yeah, the compensation job still takes care of like really big failures of systems and things like that.
We really focus on differentiating unrecoverable exceptions versus recoverable exceptions, right? So the compensation jobs are only capable of handling recoverable exceptions like network or anything like that. But then we make sure on the we make sure it gets delivered somewhere. So the unrecoverable exceptions always have to go to some queue, some log, some ticketing system. Generally basically talk about your ultimate messaging strategy. It's like traditional message strategies have dead letter queues. Like, I don't know what else to do with this message and put this dead letter queue. Our dead letter queue is actually Jira. So we don't know what else to do, we'll create a Jira ticket. For somebody to look at and figure out what to do, so that nothing falls in the floor.
Right. And in general, I think that's probably the safest practice, is to have it go to a human. When it's an unrecoverable error, you probably need to still address that problem somehow. Most of the time, that's an important thing that needs to happen, so someone's got to deal with it. So this is the kind of checklist I've come up with for Grails microservices. And I don't know if you've been following, but recently Martin's Fowler, yes, thank you. Can't speak apparently. Did a blog post. You must be this high to do microservices. This tall to do microservices. I was a little happy because I didn't have anything wrong. I have a couple extra requirements. So one of the main requirements is a low overhead to start projects. And by new projects, I don't mean like big initiatives in the company. I mean, if I want to take a new app and put it into a server, it needs to be very easy for me to do the repo, the continuous integration, the server build out. Everything needs to be very, very low barrier to entry for me. And then next, I say you have to have an internal Maven repo. I would recommend Artifactory personally, because they're here and they sponsored. So no, they're actually really good repo, and it's really easy to use and set up. But without that, you're going to be constantly constrained by oh, we can't share this plugin, we can't share that. And now I've seen a lot of Grails developers say, oh, I can just use whatever Grails plugins there are, but internal plugins released to internal Maven really work well. And I don't know if anyone has much experience using them, or if everyone else is using that as a standard practice, that'd be great. But most of my experience, that's not the case. So you have to have automated deployments, because we don't even, when I say we spin up a dev box, I don't deploy to the dev box. I get a button in Bamboo, and that deploys to dev. I don't even, I SSH into the boxes, and I have sudo, and I can do stuff on the boxes to debug, but I don't go in there to deploy code. Like, even when we're first setting things up and trying it, I still always go through automatic deployments, and it's been the nicest thing we've done, because anytime we have a failure, we've never had a surprise going to production. We've never had ooh, why'd this deploy like somehow get half done and things like that. And our automated deploys are actually set up in such a way that they're rolling. So one server will be taken down, we deploy the app, we actually wait for that known health check that we've implemented to come back up, and then we move on to the next server. And by doing that rolling deploy, we're able to do zero downtime deploys. And we can do them pretty much any time of the day, except we don't do them on Fridays, because no one deploys on Fridays. It's a bad idea. Yeah. When we deploy to production, that's when we do it. Not on Fridays, but we always do the rolling deploys. We do the same rolling deploys in QA as well. We don't do rolling deploys in dev, only because there's usually only one box in dev. It's the same code that would run a rolling deploy if there were more boxes.
So do you have the option not to roll and deploy? Because certain kinds of deployments where you're affecting the schema of the database, you can't roll and deploy.
So right now, we don't have the ability to, like, we could do something manual and ask for that. Sorry, the question was, could we not do rolling deploys? That's something we could request. I would personally prefer to build everything as something you could do rolling deploys for, and that's something it is very hard to do, and you can do it even if you need to make database changes like that, but it will take 2 to 3 releases to be done with that deploy then, because you'll do a release that you'll have to have code that's able to look and know how to go to get the old data and the new data and do the migration, so that everything is able to, because you can wait till the deploy goes and then trigger scripts. So we've done rolling deploys not with the automated bash, but with liquid base. We have done rolling deploys with pre and post scripts that have done those exact kind of database changes. It just requires your code to know how to go to both places for a short time. And yeah, it's depending on what tooling you're using, it can be hard. Try not to have to do that is usually what I would rather do, because that's much easier. You have to have some sort of server config management. So we use Puppet. There's no reason you can't use Chef or Ansible or SaltStack or whatever works really well in your organization. Use that, but you have to have some kind of configuration management. And if your configuration management is baking images and deploying Docker containers, awesome. That's cool too. Like, whatever works for you and your ops team, that's important. But what you can't do is just kind of expect to manually configure all these apps, because as you keep adding more and more, it's just unmaintainable. And I believe that one was on you must be this high to this tall to do microservices. In my opinion, I think you need to have really good team-to-team communication, and that's something where maybe not really good, but you have to have team-to-team communication and at least be aware. If you have bad communication between certain teams, at least be aware of it and try to mitigate it somehow. But if you know none of your teams talk, don't throw microservices at them. Try to get them to talk first. Microservices is not going to make them talk. It's going to let them not talk to each other. So, yes.
How do you handle shared concerns or cross-cutting concerns so that they synchronize in your server configuration management?
So the question is, how do we deal with cross-cutting concerns in our server config management or shared concerns? In our particular case, that's all of those shared concerns become Puppet classes that are inherited by our Puppet standard library that I showed earlier. I'll jump back to that. This. So by having this Puppet, this standard Tomcat Puppet library, that's actually, you'll notice that there's this base Nagios down at the bottom. It's kind of hard to see from that angle. But down at the bottom, there's this base Nagios host group stuff. And that's a cross-cutting concern of monitoring our apps with Nagios. So that's actually built into the kind of hierarchy of our Puppet classes. And everyone gets it in our server. And so for this particular app, this is the whole config file, because there's higher up inherited classes that deal with cross-cutting across all of the little pieces. And that makes sure that we have the kind of config done the same. We get the JVM in the same way. We also have a standard JVM app web server that lets you run like a Spring Boot app as a Java jar. And by doing that, a lot of the Java concerns are actually shared. So there's a higher class that's inherited by both of them.
Can it be loaded on the fly so that they can get new variables, or is this done at runtime?
So with Puppet, you can have, it does reload on the fly with, so we're using a mastered Puppet system. So what happens is the Puppet agents call out to the master, and there's a variable length of time. So it's not a forced do it at this moment. So what happens is a variable amount of time, at some point, all of your servers should look the same, but it's not guaranteed to be at a certain moment in time. And that's actually so you don't get the stampeding herd problem. So everyone doesn't hit at the, like, oh, it's 1 o'clock, let's all go check the server configs. Right now, we don't have it auto reload the Grails config. So for our particular Grails app, it doesn't auto reload. We require a restart. And we only did that because of some instability with how Hyra and Puppet was working for us. At this point, there's no reason we couldn't change it to have auto reloading, but we would want to do it at the Grails layer, because you want it to constantly reload from the config file in the system. What you don't want to do is have your config management system bounce Tomcat for you, because what happens is there's no guarantees on when that happens. So the guarantee is it doesn't all happen at once, but there's no guarantee that your 2 apps of the 100 that is in that one cluster doesn't happen at the same time, and you just knock out your entire cluster. So you can't have it, especially if your Tomcat boot time is more than a few milliseconds, you definitely don't want to do that, which if anyone's got a Tomcat boot time of a Grails app in a few milliseconds, you should come talk to me, because I would like to see that.
This is because you're loading in config files rather than data files.
Yeah.
Okay.
Yeah, and yeah, so we actually generate a standard Groovy config file that is so on the build config you can set what property, like where to go look for everything. We just have a known file location as one of the options, and so that's the override that will override anything built into the app. Any other questions on Puppet? So here are the open questions. What's the correct size of a microservice? And that's just a general open debate and question. And I have my personal opinions about the right size for them. I'm sure everyone here does. And if you don't have one, as soon as you start doing this, you'll get a general idea of what you want it to be. The other is pure REST versus RESTful. Right now, we're doing pure REST, and I think it's working pretty well, but I still see a lot of people, not inside the company, but a lot of people elsewhere push back and want to do more RESTful things. So when I say we're doing pure REST, we only use the only verbs are the HTTP verbs and things like that. The other open question is centralized security versus decentralized. And I think that's a really interesting area to talk about. And what happens is with centralized security, everything's managed in one place. It's all very good, but what now you have is a single point of failure that you have all of your microservices now pointing at, which not the best. So if you can find a way to decentralize it, but still manage it in one place, that would be really nice. But what I haven't seen is a way to do that in the current ecosystem. There's attempts, but I haven't really seen the silver bullet yet. So that's what I have. If you're thinking about doing microservices, make sure to complete the checklist first. I think it's important. There's a link there. And I have plenty of time to talk much more in detail about anything you'd like. And if you'd like to kind of talk about how we structure that subscription services code to do, like where we put code and services and what was jars and things like that, I'm happy to go into any of that. I just kind of want a little prompting of where you'd like to go with it. I'll go with you first, and I saw you.
You mentioned centralized authentication, like having one point that fails and then everything goes down. Could you, and I'm assuming you're talking about like an authentication server, is that in mind?
So lots of things. So for example, we could do centralized authentication in the sense that, yes, OAuth tokens, and we have one place to validate them. Or it may be clustered, but that it's still one thing. And it can still go down, and now all of your microservices are broken.
So kind of my question on that is, would it be possible to centralize it, but like make it redundant with backup authentication servers or something like that?
Yeah, possibly, but we can put a backup on a server, but one of the problems then, of course, is my thought is, oh, well, let's just add a cache. And I was like, wait, we can't cache security concerns because then I can't actively turn something off and like immediately have it affect. And if that's an okay use case, though, if you can say, yes, it's okay if there's a cache that may live for some indeterminate amount of time that allows this user to have access, I just don't think that's going to happen most times in security. It may be fine, actually, but the security team's not going to let you do it. Yeah, so you could write a flat file. Now, you could even manage that flat file with Puppet and have it somewhat decentralized and centralized. But once again, that's now it's not synchronous to turn people off. I can't guarantee, Puppet will do its best to run everywhere, but I can't guarantee that when I say kill this user's access, that it's actually killed on all of the microservices at the same time. I'll go back there and then yeah.
Can you talk a little bit about just the orchestration and how you deal with endpoints and how, like if I'm a microservice, I need to call a microservice. Do I know about this endpoint, or do I go to the central service that handles all that?
So the question is about orchestration of endpoints and how, if a microservice needs to call another microservice, how does it know where to do it? Since we're doing pure REST, all of our identifiers are URIs. So we know about who to call based on the fact that it's a URI. Now, if you're not doing pure REST, that becomes a much different problem. There's also, every endpoint that wants to create, let's say, a subscription needs to know about the endpoint to create a subscription to be able to post to it. That doesn't seem terribly bad since they need to know how to create a subscription anyway. They have to be able to create the correct body. So we don't really have to deal with that orchestration. But since everything is going through a URI, everything can go through a load balancer and DNS rules. So everything's orchestrated just like kind of hiding behind the standard URI. Now, at the conference, we've seen some very cool stuff with Ribbon and Eureka for service discovery from the Netflix open source. All of that depends on being able to go directly to an IP address of a server. So if you're doing pure URIs, you can't really use those tools because you're already saying, no, I'm going to use DNS resolution to know which one to hit because that's what I do. So I think that's the right way to go personally for our use cases because The rest seems to work really well. So.
But you do have load balancers with
Yeah, well, yes, there's hardware load balancer. There's a few of them, but they are shared. And we do layer 7 routing as well. So a lot of ours are at api.reachlocal.com/something, and then that's the load balance endpoint, and then it hits all the different microservices. And then, yeah, that will probably change in the future. We've talked about a few other options like HA proxy, but I don't know the timeline on any of that kind of stuff or when. So.
You mentioned that you run.
Yeah, I'll go you first and then else.
Do you run Spring integration apps as well?
Yes, so we run Spring integration both in Grail. We actually use Spring integration in Grails in multiple apps, and we have Spring Boot Spring integration running.
Okay. I didn't mean to put Spring integration inside of
Yep.
Grails.
Yeah, you can put Spring integration inside of Grails. It works just fine. There's no problems with it. The reason we do that is because it also has HTTP endpoints that it's responding to, and a lot of the services are actually shared in the sense that the Spring integration channel will come in, marshal the data to a certain known format, and that's exactly what the same path that is followed when we come down from an HTTP request. And once it gets to that one known format, it can go off to a Grails service and do whatever work it needs to do.
So that means you can share Grails plugins with Spring integration apps as well.
So the way we do it is, if it's Spring integration stuff, we make it just a Java jar. And since we can use Java jar in Spring, in Grails, so yeah, it works well that way. It doesn't work so well trying to force it in the other. So it's much easier to make the jar and make that work wherever you need it to work. And then enhance it with a very thin Grails plugin if you need special Grails, if you want to do any sort of Grails wiring and things like that for you. The other thing I would say is in our Spring integration, we've been using the XML file. And so we have the resource.groovy actually load in the XML file for Spring integration. And that's where we keep all of our kind of Spring integration config. And to me, it looks really nice. It works really well. We use lots of chains. And one of the components, for example, that we share is a custom logger that works inside of the Spring integration chain that knows how to log very specifically to our kind of object that we know we're passing through. And that's something very nice to share across many apps. So. Yep.
On the security centralization, decentralization thing, we're in the very early stages, just doing research and stuff for microservices and how to pull it off. I haven't been through that whole. But we're stealing a trick from SAML and our security. We're looking at having our security service basically issue a token, digitally signed. Services that start up, go and grab the public cert from the security service, and then now every service can do their own validation. The token's good, the timestamp's not too long. We keep small timestamp so it kind of totally addresses your
Right.
concern.
Right.
Turn people off instantly, but it gives you a very narrow window. So anyway, that way we're not dependent on a single service that can go down. It better not go down for longer than our time limit.
Right. Yeah, and that solution sounds really nice, and I hope you give a talk about it. I'd like to see it. Is there, yes?
So breaking up the services, now they're talking to each other over HTTP protocol, right?
Yep.
Services. What effect, in your experience with this, have you seen that has on performance?
So the question is, what effect does all of this HTTP traffic have on performance? And right now, we don't have a lot of performance problems because it's just simply the way our data is working. That's not our bottleneck. And a lot of what happens is also happening asynchronously. So like I said, REST calls can be both, but for our UIs that are basically a simple CRUD app talking to a few REST services, we haven't seen any major things, any major kind of performance degradation. If you're talking about these kind of really long chains We also would highly encourage caching at the edges. So since all this is HTTP and REST, we should be able to do it's very easy to cache at the resource layer. And you can do EH tags and all of that kind of stuff. And you can cache at the gateway, at the outermost, and work in. Right now, we are using the standard content like time to live headers and things like that for caching. So if there is an issue, you can do caching. A lot of what happens, though, like I said, is asynchronous. So it doesn't matter, like the really long chains of work that has to happen are the asynchronous ones. So it doesn't matter too terribly much that it takes an extra few seconds. In general, we're improving things that took 5 days to get them down to take an hour. So yay, we're happy. It's like, yes, we don't have to worry about that. And so we're in a particular domain. Eventually, if there's caching, there's client-side caching, you could also add varnish layers for caching in front of the app. So there's lots of different caching options that you can employ there. Yeah.
So how do you deploy the microservice? Do you deploy one per machine or per server? How does that work?
So right now we use virtualized machines with OpenStack, and we have one war per tomcat and one tomcat per virtual box. So right now, yeah, it's all 1-to-1, and that seems to work fine for us. The virtualization is fine. Right now, there's probably extra overhead, of course, but that's not a problem for us right now. The isolation and separation of concerns is more important, and being able to take things offline and do rolling deploys and things like that works much better for us. So we're not that performance constrained, though. So yes.
So when you guys started building this microservices, how did the operations team, what was their reaction? Since now they have to
Be nice.
They were very excited.
Yeah, of course.
No, I mean, the operations team, the question is, how is the operations teams reacting to the microservice architecture? I think it's like any new change. You have some people that were actually really excited about it, and you had some people that were a little resistant, and overall, they were very supportive, though. Like, there was no one trying to work against us. By doing things with Puppet, though, we were improving from not having configuration management, so that gave them much more control. So there's a lot of benefit that they gained as well from this architecture, and they have to maintain. If the servers go down in the middle of the night, they get the call usually. So the fact that we can now spin up 4 of them or very easily and make it much more redundant makes it easier on them in the long run. So
Yeah, I'd actually like to add to that.
Yeah.
So, I mean, ops people hate snowflakes. They do, right? They hate when a given app is very unique and has very unique challenges. So this was a forcing function to actually make things less snowflakes. Like, they were really excited when they realized that all of these services from an operational perspective were relatively identical.
Yeah.
So then they hear, but I would always encourage you to really spell this out, because what we had to say is, okay, we're going to go to microservice strategy. What this means to you guys is that we're going to now be deploying dozens of different services and hundreds of that means hundreds of instances across the environments. And they then were not terribly receptive to that. We said, but we're going to make them all the same from your guys' perspective. And then they really enjoyed that, because what they were dealing with and what they continue to deal with on the legacy apps is each legacy app is its own little snowflake, and they have to have a completely separate runbook for it, where all the microservices have basically 2 runbooks. Is it on the is a microservice on JVM, or is the microservice using Ruby? Those are the 2 runbooks that they follow for all of them.
yeah, him and then.
Did you ever think about taking the ownership of complete microservice? Because one of the things of microservice is continuous delivery, so you can do deployments as early as possible. So did you take any look at taking the complete ownership, even deploying into production?
So the question is whether we looked at taking complete ownership of the kind of config management. By looked at, you mean I asked for, because I asked for all of the things? I'm the guy that always asks for access to do everything. That's just wasn't a good idea in our company, and it wasn't. We share ownership though, so I'm very actively. It's not like they write our Puppet files. We write our Puppet files. We work with the operations team. It's a shared responsibility, and that's working really well. And I get why every once in a while they're like, we have to figure out a naming convention for this. And if you're looking at your one app, it sounds, oh, it's just a pain. I don't really care. But then if you go actually have to do a pull request into the config management, you're like, okay, I get it. I'm sorry. Everything's called server URL. So, yeah, I like the shared approach. I think that works very well, and I think it embraces DevOps quite a bit, and I think that's important. Buzzword. Yeah.
Real quick question. So all of your tomcats are configured the same with respect to heap size and how much resource they get from the
They're
machines, is that correct?
they're all configured the same way per application. So if we look in the config,
When you say application, you mean per microservice?
yes, per microservice thing. So this thing has a heap min, max, and permgen that we can configure per subscription API or other service API.
So you are authoring, some things just need more memory care than others, correct? And some need more horsepower. So you're configuring it by what the microservice does.
We can, yes. Most of the Grails microservices right now are all about at the same level. They all operate, but like I said, you end up with a size that feels right for microservices. So if you end up with a size that ends up right for microservices, most of them end up working about the same amount of memory as well. So I think that's it, unless there's more questions. Thank you, everyone, for coming, and I hope you enjoy the rest of the conference.